basically.
Yeah, thank you. I'm really excited. Therefore, I'm smiling all the time. I'm sorry for that. And on to the second question. Your work on capsaicin led to a series of findings that uncovered the molecular roots of pain. We wonder, how did you come to study chili peppers? And I know that you get this question a lot, but it's really interesting, so I had to ask it anyways.
All right, so there's two reasons that we study chili peppers. One is really the history of discovery in this field. So we were not the first people to know that capsaicin from chili peppers is an important agent for activating specific subsets of sensory nerve fibers that are involved in pain sensation. That was really work done in Hungary in the 1950s and 1960s by Jansko Gabor and his collaborators, and they showed that the studying chili peppers was very popular in Hungary because of the paprika industry, and they showed that capsaicin can be used to identify a specific subset of somatosensory neurons that are involved in pain sensation. And the mystery really was, how does this work? And is there a specific molecular player? So when we came into the field as sort of naive molecular biologists interested in pain, that really stood out as a critical and central question that many people had been trying to answer. So the idea of using chili peppers to study pain mechanisms was not ours. It was something that we took from the field, but we knew that it was, as molecular biologists, we knew that that was one critical question that we could really, if we figured out what the answer to that was, that would be a major contribution. But the other reason that we were interested in this is because when I was a graduate student working in the area of yeast genetics and biochemistry, I started thinking about what I wanted to do for the future. And I got really fascinated by the idea and the history of using natural products to understand biology. And there's lots of examples of this. Many of the drugs we take are inspired by the use of, by the discovery of mechanisms that have been revealed by the use of natural products. But I got really interested in things like,
you also use menthol. So
yes, we use menthol and wasabi. So, but when I was a graduate student many years ago, I got interested in understanding how things like hallucinogens work. How does peyote work, and how do things like magic mushrooms work, and psilocybin, and all those interesting compounds that generate hallucinogenic effects. And so that's why I got interested in serotonin receptors when I was a fellow. But that got me on a trajectory of being interested in using the natural world and natural chemistry to identify key molecules in the brain or other parts of the nervous system that are involved in signaling and neuropharmacology.
So can we say that your curiosity when you were a teenager led you to win a Nobel Prize?
I think curiosity is the key word. I think that's exactly right. I think that what drives you every day when you go into the lab is curiosity. Look, most of the time we start experiments, they don't work, and we have to wrestle with, failure and trying to get things to work at the bench and trying to get experiments to work. But what really gets you out of bed every day and gets you into the lab to try new things is your curiosity and a drive to discover something new. And so, yeah, absolutely. My father used to tell me that I used to take things apart when I was a little kid, like old watches and things like that. And he used to tell me I was very good at taking things apart, but not really at putting them back together. So I took a lot of things. So I think it's really curiosity to understand, what makes something work and what all the little components are. And it's kind of as simple as that.
Perhaps your father thought that you would be a mechanical engineer, but it's lucky for us that you didn't.
Well, it's probably lucky for people who drive over bridges and all that I wasn't a mechanical engineer, but he was an engineer actually, and he did want me to be an engineer, but I decided to be a biologist.
That's interesting to hear. I have seen many of your interviews, but I didn't hear that before. So I should go on, unfortunately. So I would like to ask you now, is how objectively do you think a machine can measure pain? Like, we know that there has been ongoing research using brain imaging to evaluate pain, but isn't pain more of a subjective thing?
Yes. So this is a big issue in working in the pain field, is having objective measures of pain. And it's actually, a very big issue in the pharmaceutical world in terms of drug development. So we talked about that earlier, but one of the there's two problems at least, and this is not my area of expertise, but something that I've thought about a little bit. One is, of course, we study mostly nociception, which is something that you can quantify a little bit more. That is how sensory nerve fibers detect noxious stimuli. But pain is really a pretty complex integrative function. It's both a physiologic and emotional processing by the brain. And so you're absolutely right. Pain, you can measure pain or pain related behaviors. For example, in a mouse, if a mouse lifts its paw from a hot surface or from a mechanical stimulus, and you can measure that. But in humans, of course, pain is a declarative function, which means people tell you about the pain, where it is, what the quality is, what the quantity is. How much does it hurt? Where does it hurt? Is it burning? Is it pricking? Is it tingling pain? And those things are hard to measure unless you can interview a person. But even still, it's rather subjective and different from person to person. And the other problem in clinical trials that I think has really been a factor for drug companies is that there's a very large placebo effect. So in clinical trials, the placebo effect, namely, for example, if you give a sham treatment to someone and they feel relief, that's almost 50% of the scale. So, your brain has and spinal cord has some very potent mechanisms for diminishing pain intrinsically, and this is a problem in scoring drugs. So, yes, this is a big problem. I think that it's a challenge, I should say, rather than a problem. It's a challenge, and I think coming up with more objective ways to measure pain is really an important goal. And as you noted, Dina, imaging methods are what people are really putting a lot of effort into, and I think that will progress with time. People like Catherine Bushnell and others have spent a lot of time identifying brain regions that light up when people are subjected to noxious stimuli, and at least in the sort of acute setting where you can challenge people, that's probably the best hope for measuring pain quantitatively and objectively in human beings. But yes, I think having those kinds of measures would really probably help in terms of drug trials, in terms of treatment assessment, et cetera. But we're still pretty far from that.
Okay, so after this, actually, I want to pass the word to Betül Bere Yılmaz because she has a really great question, and I want her to ask it herself. So Betül, you can talk right now.
Hello, doctor. It's really nice to meet you, by the way. Can you hear me?
Yes, I can.
Okay, my question is actually about sensory processing disorder. As you know, many individuals who have ADHD or ASD are struggling with sensory processing issues. And I couldn't find so many papers about receptors you discovered and their relation to ADHD or ASD on PubMed. But I wonder if we can inhibit these ion channels for hypersensitive people or strengthen them for hypersensitive individuals. I mean, could we generate pharmacological agents that affect these receptors as a treatment for neurodevelopmental disorders?
Yeah, that's a good question. I don't know that there's a lot of, I don't know of any connection, certainly, between the molecules that we've identified and sensory processing or attentional disorders like ADHD or ADD. So those are very good questions. I mean, the place where we've done some work where we thought about these things is recent studies that we've done to look at pain in what we call visceral pain. For example, pain, gut pain. And the reason that we think about it in that context is because children who have some sensory processing disorders, who are sort of on the on the spectrum for Asperger's or other such diseases often have associated issues with, well, not only touch and sensitivity and but also GI hypersensitivity. So there clearly is some interaction between sensory input, peripheral sensory input, somatosensation in particular, and some of these sensory processing disorders. But it's, you know, I think it's there are not yet connections. I think the, you know, the most likely connections will be not with the molecule we've identified, but the one that Ardem has looked at, namely the piezo channels that are involved in touch sensation, because that's sort of one of the more obvious phenotypes associated with children who have, you know, sensory processing disorders. But at least to my knowledge, people are just starting to look at that. People like David Ginty at Harvard are beginning to, and people from his lab are looking at the role of sensory afferents and somatosensory neurons and the wiring diagram there in children who have sensory integrative disorders. It's really a sort of a beginning field. And the reason it's beginning is because this is now the first time that we have molecular markers for all these different sensory neuron subtypes. The other challenge there is developing models in mice that we think are instructive for studying sensory integrative disorders. And that's sort of a challenging area as well. But that's a great question because there's clearly issues for many kids there. And the question is whether it's peripheral or central or both.
By the way, your answer is pretty important for me because I also have ADHD.
Mm-hmm.
Thank you so much for answering.
Yeah, you're welcome.
I wanted to give the control to Dina again. Thank you.
Thank you.
We are running out of time, and my director texted me that he wants to ask a question.
Okay.
So I would like to introduce Bera Gülhan now.
Hi, Professor.
Hello.
First of all, welcome to our meeting. I'm Bera, by the way. As the director of the neuroscience branch of our neuroscience committee, I would like to thank you for accepting our invitation for this very special event for us. My question was, we as students of medicine are very eager to make studies and do research in the future. As future Nobel winners in medicine, future Nobel winner candidates, what should our motivation be is to accomplish such achievements like yours? I know this is a general question, but seeing someone having accomplished the Nobel Prize, I'm more than curious to know how you managed to keep your stamina for reaching your goals, because scientists can have challenges, and when they cannot overcome these challenges, they might face some motivation losses. So how were you able to keep your morale and motivation very high to overcome these challenges and reach your goal of the Nobel Prize?
Yeah, that's a very good question. I think, well, first of all, I should say that, you know, I didn't go into science with the goal of being awarded a Nobel Prize. I mean, I think that prizes are wonderful, and they recognize you and your institution and your students and fellows and trainees and the field. But you know, that shouldn't be the motivation because it's just not what we think about every day. But the question you raised is an important one. So what's motivated me is really just curiosity. And you're right, you know, there's a lot of times when you're in the lab and things aren't working. When I was a postdoctoral fellow, I switched fields completely, going from, you know, studying enzymology and yeast genetics to trying to use molecular tools to understand the nervous system. And that was a big change for me. And what it meant was that I had a lot of learning to do. And I was in the lab, in Richard Axel's lab, for about 4 years before anything worked. That was a very challenging time because I had a successful graduate career, and then it sort of came to a screeching halt. And I had to keep going. And there were times, you know, we're all human, so when we face frustration, we all have a lot of self-doubt. And there were times when I thought, well, maybe I just got lucky previously and things worked and I really don't have a talent for this. So yeah, you know, you have to believe in yourself because it's very easy for all of us to lose faith and to doubt our capabilities. And you always think that everybody else is doing better than you, right? Because you always look around and there's always someone for whom, you know, something's working. And you have to know that, you know, as I always tell students in my lab, I always say, every dog has his day. You know that expression, which is that at some point, if we keep at it and we keep working, we will be successful. And really what drives success is your passion to do the work, with the realization that that not everything is successful in science. That's just the way it is. And if everything you do is working, then what you're doing is too easy and you're not challenging yourself. So, but one of the things that I like is one of the reasons that I started working in a lab when I was younger in college is because and I think I have a little ADHD myself, actually. I had a hard time sitting in classes and just sitting there and doing didactic learning, and working in a laboratory really was an outlet for me where I could use my hands and do something creative. It was like a hobby. And so for me, coming into the lab when I was a student was a way to do something that I enjoyed every day. And even if the project wasn't necessarily progressing in an area that, was clear yet, I got a lot of enjoyment out of just coming in the lab and getting little experiments to work and taking joy out of what I would call the craft of doing science. And also talking about science with other people and taking some joy out of their successes, even when, my own work was still, lagging and I was waiting for, that big aha moment. So I think it's a few things. I think it's keeping up your curiosity. I think it's about having realistic expectations that a lot of what you do will be failure, and but you keep thinking, and it keeps you on your toes, and you keep hoping for, the light at the end of the tunnel. And it's also just engaging with other people and staying excited about science in general, even when your own experiments, are not quite there yet. And I think it's also having faith in yourself. There's a lot of times, and this is true for anybody, not just a scientist, but anybody, as we all know, doing something creative. If you're a writer, or you're an actor, or you're a musician, you're always questioning yourself as to whether you're creative enough. Are you as good as other people? Are you doing things that are really what you want to do? And so I think this is not, being a scientist is not different than anybody else who's doing something creative. And the wonderful thing about science is that it's not like a regular job, right? Where you go in at 9 o'clock and you leave at 5 and you do something very routine. You have the freedom to do what you want to do and to work on the things that you want to work on, at least to some extent. And the flip side of that is that there are no guidelines, nobody's telling you what to do. So you have to determine that for yourself, together with your mentors and your collaborators, etc. And so you get this freedom, but you also take on this kind of risk. And that's the back and forth of this profession. I would say the other thing is that when you get a little older in the business, you also get a lot of gratification from training other people and being mentors to students and fellows. And so that's part of also the positive side of doing this, that, it's not just about you making discoveries, but it's about helping other people, especially younger people, make discoveries and create a career in science. So there's a lot of good reasons to do this, but you have to be persistent, and you just, have to believe in yourself.
Well, thank you so much, Professor. I appreciate your answers.
Thank you for asking that good question.
Following Bera's question, I think it would be suitable to ask what is it to be successful, hobbies or social activities?
I'm sorry, could you repeat that? It broke up a little bit.
I think my internet connection is unstable. How hard do you need to work, and do you have time for family, hobbies, or social activities? Yeah. And what advice could you give to early career scientists?
Yeah, that's another good question. The work-life balance. And, I think we all have to maintain that to some degree, but, doing science, like anything else, as I said, any other creative activity, takes a lot of time and passion and attention. And so, it's not a 9-to-5 type of endeavor, and you have to kind of put your heart and soul into it. And there will be times when you have to work harder than others, where, there were times in the lab when I was working 14-hour days in the laboratory. And even now, on the weekends, I do a lot of stuff for people in my lab, write letters, work on manuscripts. So I would say that, it is a consuming occupation. It's not a 9 to 5 job. But on the other hand, and especially because you get to sort of dictate your own schedule, you're not working on somebody else's clock, you can have freedom to, have a lifestyle that accommodates other things. I mean, people in my lab, they have a good time. They go out and go skiing, and they have family. And I have several people in my lab who have children. I have 2 women in my lab right now who've had babies during the time in my lab, and they're, incredibly devoted and productive, and as productive as any other member of the lab. So you can have a family. You can have, enjoy the things in life that other people enjoy. I think you can strike that balance. But I think, it's really driven by you from within. So how hard you work and what you do really depends upon your own motivation. But I think you have to be self-motivated to do this. And there are times when you will have to put a lot of time into the lab and, to get things done or to finish up a project or whatever. But, being a scientist doesn't mean that you have to be a monk and hide out in the lab 24/7. Everybody in my lab has a personal life that I think they find pretty fulfilling. They're all very well-rounded people. They have hobbies. They have husbands, wives, children, etc. So, and I have a child, and I'm married to a woman who's also a great scientist, and so maybe that helps a little bit. But we engage with our families, and we talk a lot about science. My son says we spend too much time talking about science, but but we engage with our families and we have a normal lifestyle.
So
But when you're a student, in particular, you're focusing pretty hard on your work, and it's like going to law school or medical school or whatever. But you can make both. There's room for both.
So you manage your time to spend time with your family for work and also reading my mails. And I would also like to thank Ms. Lidiana for replying my endless mails. Thank you for that again. And I think also now Elif Sude Barutçu would like to ask a question, and then we will have Nida talking as a closing remark, if it's fine by you, because
Yes, that's.
we are coming to the end. Yeah, okay. So Elif, can you ask your question right now?
Yeah, can you hear me?
Yes, I can.
So hi, Mr. Julius. It's been an honor for me to ask you this question in person. On one of your interviews, you mentioned that we are responsible for our own creativity, and also you hinted the liaison between the creativity and art. What do you do to fulfill this responsibility? How do you improve your art?
I stay engaged. Well, now I don't work in the lab anymore because I'm old. So I don't know how to do any of the techniques that people in my lab do. But, I stay very engaged with people in my lab. I talk to them all the time. I read the literature. And the door to my office is always open, and people are welcome to come in, and I walk around the lab and ask them how it's going. And I speak to other colleagues, and, I help them set up collaborations to extend the breadth of what they can do, because my lab is small. I don't have a big lab. I've always had only about 7 or 8 people in my lab. And so, we can only cover so much ground. And so to be creative, I think you have to use new techniques and new approaches. And so I help people establish collaborations or start new things in the lab. And so my role in terms of maintaining creativity is staying intellectually involved, encouraging. I think people in my lab, when they've been asked, like, what's the best thing I do for them as a mentor, I think they say that it's always encourages them to get out of their comfort zone. So what that means is that, we all like to do the things that we know how to do well and do them over and over again. But the real challenge is to do new things that we're not so sure about. So I always encourage people to push that envelope and do new things so that they can extend the scope of their study. So I think that's how I kind of help them with creativity. And I think that, the other thing too is that you can go to a lot of meetings and read the literature, which is important. But sometimes you just need some quiet time to think for yourself, so that you're not just thinking about the same things that everybody else is thinking about. And you're maybe thinking about some new things without kind of all the input from everybody. And you just kind of sometimes sit quietly and try and think about a new way or a new problem to approach. And I think that's really important. And when you have those ideas, I think it's important to share them with people in your lab and your collaborators, and kind of encourage them to venture out into some new territory, which is always a little frightening. But I think that's the secret to making new discoveries.
Thank you
So-
for the inspiring answer.
Yeah, thank you so much. So last but not least, I would like to introduce our president, Nida Yılmaz, for the closing remark.
Hello, good evening. First of
Hello.
all, I want to introduce myself. I'm Nida. I'm the head of the Scientific Research Committee. And it was our utmost pleasure having you here, Professor. We highly appreciate your acceptance of our invitation and the inspirations you gave us. On the behalf of Bezmialem Vakıf University Scientific Research Committee, I would like to thank you and all other attendings. In order to show our gratitude for Professor Julius, we made a donation to the Make-A-Wish Foundation Association, and I want to show you our thank you for everything again.
Thank
It was a
you.
big honor for us.
Well, this was an honor for me. This is the best thing that I do. I think the Nobel Prize is a wonderful thing, but the best thing is that it gives me the opportunity to speak to folks like you. And I really, as soon as I got your invitation, I get a lot of these invitations now for Speak at Place, but as soon as I got yours, I wrote to Lidiana, my assistant, whose husband's actually Turkish, and I said, I have to accept this invitation. And so she set it up right away. This is the
me in Turkish.
what's that?
She writes sometimes in Turkish, and I was
Oh
like,
yeah,
wow, okay.
yeah.
She
She's a
put a great effort. Yeah, okay.
she can write in many languages. She's an amazing woman. Anyway, but this is the best thing I think that I do, and it's really exciting for me to speak to all of you. It's really my, you say it's an honor for me to be here. It's my honor to speak to all of you and see all these faces of people who are going to do great things in science and medicine. I have a lot of colleagues actually that I know from Turkey who are here in the States and other places, and so you folks have a great legacy of science and learning and education that I know will propel you forward. So, and I have visited Turkey. It was one of the best trips I've ever taken. It was just a personal trip that I took with my wife and kid, touring up and down, going to Ephesus and all this. And it was really one of the most exciting and wonderful trips we've taken. So I know that there's so much talent in Turkey, and I hope that you all have the passion and the self-confidence to move forward and do the things that really inspire you. And thank you for making that donation. That's really wonderful. And for setting up this, Dina, for setting this all up for us and letting us get together just before the new year. Thank you so much.
Thank you.
Thank you. So our program is, I think, finished, but we always want to see your face like these kind of activities, of course. We are really honored to see you in here today.
Thank you so much. Have a wonderful new year and productive and a healthy new year. Stay healthy. And I hope to see you at another time in Turkey or in the US.
Yeah, we will hope to see you as our guest sometime.
Yep. Thank you. I'd love to come back to Turkey. All right, everyone. Have a good holiday
Professor,
season.
can I ask something? Thank you very much again. We would like to take a picture together as a memory. If
Okay.
anyone would like to join us, they can open their cameras.
I'm trying to get this, get the sheen off of the sun off of. Here we go. No, maybe that's better. There we go.
I'll take another one. Okay. Thank you
All
very
right.
much, Professor, again. We appreciate
very much.
everything you did today. Of course.
Thank you for your time. I appreciate all your time and for inviting me to do this.
Okay. Well, have a good day then. See you.
You too. There's my wife.
Hello.
Also a scientist.
Hi.
Hi.
Getting ready for the holidays. All right, everyone. Stay well, and I'll see you soon, I hope. Thank you again, Dina, for setting this up.